Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of composition of two transformations. So here we have two different transformations which are linear transformations and they are defined as T and S. So the idea is T here transform this vector space to this vector space. And S transforms, okay, so transform from this to this, and S transforms the same here, this one, to another one, okay, to another vector space. And the question is, we would like to find the direct approach, which is direct from T to this part. So direct from transforming this to this, to the end. All right, that's the idea. So let me just try and visualize the whole process. Imagine we have this input here. V here is the input. This is input, this one. And then we have this transformation T here that takes this input. So the input here will be supplied to this function. They will do some calculation and the result of that is given in this box. So the result of that is the result of giving this input to function T. So you give this input into this function, you will get the result. Here is actually the output of this function. So the output of considering this function. So let me just write down as short as just output. Okay. Now there is another transformation which is called S, and S here considers this output as an input. So here it will be an input for S. And therefore, the result of that will be, well, will be something that looks like this. We have function S, and the input that is given to this function S is this thing. So we're just going to write down the whole thing here. So this is the input for function S, and therefore this is the result of it. So this is the output. So what we are looking to find is, we are looking for this path of giving this input direct and get this output directly without going to this middle part here. So you're looking to find what is this function, and this function is labeled as composite function, where you have the composition of two functions S and T. So S composed T. So this is a function just like T and S, but this is a direct function from this point to this end right here. So the result of this function is going to be equal to this result. So this one here is going to be equal to having this direct function. We call it the composite function, composition of two transformation. Okay, the name here is defined as composition of two transformation, and we're going to give the input to that. Okay, the input here is just V. So that's the idea. This is what we're looking to find. Okay, right. If you look at this theorem here, it says when you're looking to find the composition of two functions, we can do that if we consider the standard matrices. So the composition of two functions can be found easily if you are able to find their standard matrices, and this is defined as standard matrix of S multiplied with the standard matrix of T. And to understand this, we shall look at the example later on. Okay, right. Now let's look at this example here. So here we have T as a linear transformation. It transforms vector space with 2 dimension into another vector space with 3 dimension. You can see it clearly that here we have 2 inputs, 2 dimension, and then here the result is 3 outputs, 3 dimensions, 1 output. Yeah, so this is 3 dimensions, 3 components here. And then we have another transformation defined as S. So here we have the input of here is a vector space with 3 dimensions. So you can see our input here has 3 components, 1, 2, 3, and then it will transform this input, and the result here we're going to have 4 components, vector space in 4 dimensions, 1, 2, 3, 4. And again, what we're looking to find is we're looking to find a direct way. So for example, here it starts from input given to T, and you get some output. This output also becomes an input, which is given to S, and then you get this output. And what we're looking to find is we're looking to find for direct way from this point to this point here, and this is defined as the composition of 2 transformation S and T. So you're looking to find this part which transforms vector space with 2 dimension. This is the beginning to the end. So it's going to transform this vector space of 2 dimension to another vector space with 4 dimension. Okay, so in order to do that, I think maybe what you can do is, well, we can think of it as this is the input. Input is x1 and x2. This is input. So imagine we have the transformation T here, and T has this rule given that you can use. So when you supply the input into this function, the result that you will get is given by this. So you will get result x1, 2x1 minus x2, 3x1 plus 4x2. So this is the output. Now, it also becomes the input because then you consider transformation, linear transformation of S, and the linear transformation of S will consider this input here as defined by this one. The input that we have is y1, y2, y3. There are 3 components in here. And in other words, you can think of it as this is y1. This is just a little note I'm putting right next to it. So this is like y2 and this is like y3. And in order to know what sort of output that you will get, you will have to consider this rule given here. So this is the rule that is given by this transformation S. And it says here for the first component, you have to consider having 2y1 plus y3. So what is y1? Y1 is this one, and y3 is this one. So 2y1, which is x1, just substitute this input here, plus y3. So y3 is the whole thing, 3x1 plus 4x2. Okay. And 3y2 minus y3 is 3 times, this is y2, 2x1 minus x2, minus y3 minus this one, 3x1 plus plus 4x2. Okay, and the third one is y1 minus y2, so y1 minus y2, this one, and finally y1 plus y2 plus y3, this all added together, x1 plus 2x1 minus x2 plus 3x1 plus 4x2. And of course we have to simplify that. So I'm just going to continue this. This is state output S. So this is the output. And I'm just going to like simplify the result. I'm just going to write down the simplification of this result. So this is equal to 2x1, 3x1 together. So 5x1 plus 4x2. Okay, done. This one is, well, this is 6x1 minus 3x2 minus 3x1 minus 4x2. So it becomes 3x1 minus 7x2. Done. Okay, this one is x1 minus 2x1, negative x1 plus x2. And this one is x1 with 2x1 with 3x1 is 6x1. 4 minus x2, 4x2 minus x2. This is 3x2. So based on the result here, I can then consider that this thing here, okay, given input x1 and x2, the result is going to be in this way. Oops, sorry. The result is 5x1 plus 4x2 and so on. Oh, okay. I've just skipped one blank space, but that's okay. So the result will be 5x1 plus 4x2, and then 3x1 minus 7x2 minus x1 plus x2, and here is 6x1 plus 3x2. So this is the rule. This is the rule that you will consider that will give you the end result straight away. So this is the end result. This is the beginning without actually going to the middle part. So next time if somebody asks you, hey, what is the result of this 1 and negative 2, you can just plug in this into this rule here and you'll get the result straight away. So you don't have to go through the process where you plug in into this and then go on into this. So you skip the middle part. Okay. Now, is there an easy way to do this? Is there an easy way to do this? Yes, of course, which is we consider the standard matrix, which is given in the theorem just now. So for example, if you want to find the composition of these two transformation here, this is equal to finding what is the standard matrix for S and the standard matrix for T. Okay, so now let us look at the rule given by S. This one here, okay? So now I'm going to talk about the standard matrix. Okay, so for that purpose, I'm just going to erase this whole thing, yes? So based on this, so this is transformation S, you can create a standard matrix. We call it standard matrix of S. Based on the component that you have here, you can see we have component y1, y3, y2. So it should give you an idea that we are going to consider component y1, y2, and y3. So when you consider the first line here, it is 2y1 plus y3. It means we have 2 for y1, 0 for y2, 1 for y3. In a similar manner, for this one, we shall have 0, 3, negative 1. For this one, we shall have 1, negative 1, and 0. And finally, for this one, we have 1, 1, 1. So this is the standard matrix for S. Next is the standard matrix for T. And again, you can see here we have x1, x2. So we only have x1 and x2. So we shall have x1 and x2. So the first line here, it means we have 1 x1, 0 x2. For the second line, 2, negative 1. And the third line, we have 3 and 4. So to find this, we can construct the combination of these two standard matrices. So we'll consider multiplying them together. Well, here we have this one here, which is given by, according to the theorem, you can see this is given by this. Okay, so we have S multiplied with this T. So what is S? S is the whole thing here. We have 2, 0, 1, 0, 3, negative 1, 1, negative 1, 0, 1, 1, 1. And T here is 1, 0, 2, negative 1, 3, and 4. Okay, so we're just going to multiply that. And the result is going to be, well, so here is the first row, first column. So 2 is 0, 3, so this is 5. This one and the second column, 0, 0, this is 4. Okay. Next is this one with this one. So 0, 6, negative 3, so this is 3. And then this one with this one, 0, negative 3, negative 4, negative 7. This one here, 1, negative 2, so negative 1. For this one and this one, 0, positive 1, so this is 1. Okay. And this one here, 1, 2, 3, which is 6. This one and this one, negative 1 plus 4, which is 3. So based on this, well, we know that I'm just going to write down this here. Therefore, if you have this composition of these two transformation and you give vector x1 and x2 to this function, the result here is going to be represented in this way. So this is x1, this is x2. So here is x1 and x2, of course. So for the first line, the result is going to be 5x1 plus 4x2. The second line here is 3x1 minus 7x2. This one is negative x1 plus x2. And finally here, 6x1 plus 3x2. So the result here, as you can see, is similar to what we have done in this part here. So it is similar, okay? Right. Let's look at the next example here. We have two types of transformation defined as T and T prime. So the order is in that way. So we start off with transformation T. We have input and we've got output. So the output here is going to be input as well, and it will be given to this transformation T prime, and you will get output. But this question is asking you to find this one here, T prime compose T. That means the composition of these two transformations. So So when t is behind it, it means that you start from t. So you start from this input, you do the t transformation, and you go right next to it. So this is the part here, and it is defined as this. Okay. Right. So the question is asking you to find what is the rule given here, and then it gives you a vector and asking you to find what's the output of this. So for example, if the input here is given as 2, -1, and 1, what is the result that we are looking to get here? So this input is given to this function, this composite function, composite transformation, composition of two transformations. Well, those are the names. And what is the output here? So that is the question. Okay. Of course, you can do this in the way which I have mentioned just now. For example, you go from one process to the next process, but as I have mentioned previously, there is a simple way, easier way to obtain the rule for this. So that can be obtained if you consider standard matrices. So this here, the composition of these two functions here, we can consider the standard matrices, which is in this order. So be careful with the order, multiplied with t. Okay, and to do that, we're going to start off with creating the standard matrix for t prime. So the standard matrix for t prime, we have to look at this part here. Okay, let me just erase this to clear some space. Right, for that one, notice that we have x1, x2, x3. Therefore, here the matrix is x1, x2, x3, and it is given. If you look at the first line, it will be 1, -1, 0. Second line will be 0, 0, 1. Third line will be 0, 1, 0. So that is the standard matrix for t prime. Next is, so I'm just going to put this right here. So 1, 0, 0, -1, 0, 1, 0, 1, 0. Now for t, this is what you're looking for. Again, we have x1, x2, x3. So you know that you're going to have x1, x2, and x3. So for the first line, it will be 2, 1, 0. Second line will be all 0. And third line will be 1, 0, 1. Okay. And I'm just going to put it right next to it. 2, 0, 1, 1, 0, 0, 0, 0, 1. So that one, if you multiply these two matrices together, so first row, the first row, first column, 2, this is 0, this is 0, 2. Row and the second column, this is 1, the rest is all zeros. With the third column, 0, 0, this is also 0, so the result is 0. Okay. For this one here, we have two zeros, so this is all 0, 1. Okay. 0, 0, so 0, 0. This is also 0, that means this is 0. This is quite easy when you have a lot of zeros. It makes calculation so much simple, yeah? 0, 0, 0, 0. This is 1 and 1, so here is 1. Okay, finally, the last row with this one here. Well, 0, 0, 0, 0. Last row, second column, 0, 0, 0, 0. This one and the last one here. So 0, 0, 0, 0. Okay. Right. And based on that, we can we can consider the rule for this is given by this matrix here. Okay, so I just need some space for that. Okay, so therefore this one here, if you are given the output of this is the beginning, the input, sorry, you give the input here to this composition of two transformation, x1, x2, x3. The result is going to be, so again here this is x1, x2, x3. The result is going to be in this way. This is the rule. It will be 2x1 plus x2 based on this, and then based on this it will be x1 plus x3, and here it will be 0. So this is the rule or the function if you give the input and you want to observe the output straight at the end of it. So it goes from this input, the beginning here, it goes straight to the end. So they bypass the middle part, okay? Right. Next is, so we have solved the first part of this question. The next part is asking you to find what is the result if you are given this particular vector. So what is this result here? Okay, so this result here, we have this function and you are giving this vector, this input to this particular function where the rule is given by this one. It says you need 2x1 plus x2. So of course you can make a little note here. So this is actually x1, this is actually x2, and this is actually x3. Okay, so 2x1 plus x2, that means 2 times 2 is 4, 4 minus 1 is 3. Okay, next is x1 plus x3. So 2 plus 1, x1, x3, 2 plus 1 is 3. Finally, this one is immediately 0. Okay, automatically it's 0. And so this is the answer to this part. Okay, that's all for now. Thank you very much for watching, and I'll see you in the next video.